Okay, good day, everyone. We'll get started. Okay, we're gonna continue where we left off from last class, for last Wednesday, right? So we'll talk about the effective interest rate, and it's from section 3.2. So let's first of all open the PowerPoint. Okay, so let's go to the Blackboard, open the PowerPoint. And do you have any questions before we get started? Okay. And this coming Friday, if you have any question on the project number 4, then we can talk about it, right? We can definitely, I can give you some guidance, help you complete the Excel project number 4. Okay. So let's move on to the effective interest rate. So you start with the nominal interest rate, and from there we try to convert it to the effective interest rate. Right. Yeah, let's start with the nominal rate, and we're using a process and then formulas to convert it to the APR, which is effective interest rate. And that's what we talked about last time. We're here, and then this is the shortcut formula we utilize to.
Professor, are you sharing something?
Yeah, not yet. So yeah, I forgot to share the screen. Yeah, you're right. Okay, so here you go. Can you see the screen now?
Yes.
Okay, great. So basically, I just mentioned, we stop at the nominal interest rate and we try to convert it to the effective interest rate, which is APR. And APR is what we call the real borrowing cost, right? Meaning, if as a borrower, this matters more because tells you, give you the clear idea what's the real borrowing cost. And we basically use this shortcut formula, effective interest rate formula, to calculate effective interest rate, given R here is nominal interest rate, and then N is number of compounding periods, interest period or compounding period per year, and then effective interest rate, same thing as APR. Okay, so if you near future you have to borrow money from the bank, or maybe like get a mortgage or car loan, something like that, you always need to look at the APR because that matters more, right? That actually it's connect to your actual interest. Okay. Now, actually, we went over this practice example. Let's look at this one. Let's utilize the formula. So I over E, right? Effective interest rate equal to 1 plus R over N to the N power minus 1. Okay. So let's utilize this formula to get this effective interest rate for these two cases. Determine the effective interest rate, or you can say APR. So you're looking for APR of an account paying 4.78% compounding weekly. And since it's compounding weekly, now we know that N equal to 52, right? 52 weeks in a given year. So the compounding periods are 52. The rate is given, it's 4.78%. And if you turn into decimal number, it will be 0.0478. From here, we know both things, number of compounding period and the rate, then we good to go. All right, so for A, so effective interest rate equal to 1 plus 0.0478 dividing by 52 raised to 52nd power n minus 1. And typically it's a lot easier, if you're using the Excel to get this. Okay, so let me just go here, get the Excel file open. And let's complete it in Excel. I'll share the screen with you in a second. Okay. Share that with you. Here you go. And from here, we just input the designated formulas and let Excel do the calculation for us. 1 plus 0.0478 dividing by 52 raised to 52nd power n minus 1. And that should give us decimal answers. And the original question is it's running to 3 decimal places. Is it? No, 4 decimal places. You can do the same thing, right? After you put in the formula, we can run it to 4 decimal places. So we're going to change down to 4, right? So it's 0.0489. So let's go back. So this answer turned out to be 0.0489. So this is approximately equal to 0.0489. So and then you convert the percentage, it turned out to be 4.89%. If you look at it, it's about 0.1%, 0.11% higher than the nominal interest rates, right? So that means your real borrowing cost is usually slightly higher. Okay, so that's what this effective interest rate demonstrates, right? Or give us a better idea, you know, what your real borrowing cost is. All right, so now part B. I guess I'll let you try this really quickly, spend a couple minutes, and just figure out what is number of compounding period and then rate and nominal interest rate, and you'll be able to get an effective interest rate. Right? And meanwhile, I'm gonna take a screenshot of attendance. Okay. All right, so does anyone want to share your answers? Okay, what will be the compounding period here? So it's compounding daily. That means n equal 365. And also the effective the annual nominal interest rate, again, is 4.78%, so it's 0.0478. Okay, now we just apply the formula. E equal to 1 plus R over N to the nth power minus 1. So here we have 0.0478 over 365 and raised to 365th power minus 1. And one more time, you just have to put into the calculator or the Excel one more time. Let's see, 1 plus 0.0478 by 365 and raised to 365th power minus 1. And let's see what that is. Again, yeah, it's look like it's slightly higher than that. So it's 0.04490, right? So slightly higher than the compounding weekly cases. So let's go back a little bit. As you can see, the more compounding period, the higher the effective interest rate. So this is approximately equal to 0.0490. And if you turn into percentage, it's 4.90%. So the more frequently compounding indicates the higher effective interest rate, meaning you pay more in terms of borrowing cost. Okay, any question on this? Okay. And then you have some homework assignments you can from. So it's all about if nominal interest rate and effective interest rate here. So this is from your exercise 3.2 and question 7. Any question you, okay, so that's one of them called continuously, right? So I'm gonna work on one of these continuously compounding case to show you where this, how to solve this, okay? So if it is continuous compounding, it should be e to the RT minus 1, right? So think about this, let me put it here, put on the screen. Okay. So first of all, what if it's a 4.78% nominal interest rate and it's compounded continuously? Compounded continuously. So first of all, the continuous compounding formula, it's balance equals principal times e to the RT. So that's it. And then here, principal, we're assuming principal is 1, right? It's always 1. And basically, so that would make it e to the RT, basically. So, so the formula to calculate the continuous compounding in terms of effective interest rate should be I of E equal to e to the RT n minus 1. And here, R is 4.78%. That means 0.0478. And then T here is 1 year, right? So just 1 year. Okay. Now we get an E, which is E raised to 0.0478 times 1 minus 1. And again, we put into the calculator, Excel, to get a result. And if you look at the continuous compounding, actually the rate is slightly higher than a daily compounding, because for continuous compounding, there's infinitely many compounding period. So it's 0.0478 minus 1. Okay. And this turned out to be this, right? It's almost the same, but if you run it to see 4 decimal, you see this one is slightly bigger. You see this is 0.048958, And under the continuous compounding case is 0.048961. So continuous compounding actually gives us the highest effective interest rate, or APR. But typically we just run it to 3 decimal place. It look like the same, but they're not the same. Right? Under the continuous compounding, it's slightly higher. Okay. All right, so and then go back for this one. It should be 0.040, so it's about 4.90%. So the continuous compounding is the best, right? In terms of if you are a lender, using continuous compounding is the best method of growing the money. Okay. And I guess you will be able to handle the questions in your homework exercise. Okay. Yep. So let's go back to the PowerPoint. Now, this is a comparison among different compounding periods, right? So if nominal rate is 4%, under the compounding annually, again, it's 4%. If you semi-annually, then the rate go up a little bit, 4.04%. And quarterly, go up again, 4.06%. Monthly, it's growing, right? And compounding daily, continuously will be slightly higher. So as you can see, the pattern here is the more compounding periods give us the bigger or the higher effective interest rate. Periods renders higher APR. This is like, you can view that as an empirical rule, or like to best describe the relationship between the compounding periods and also the effective interest rate. Right? Okay. All right. Let's so now this is everything about the effective interest rate. Now let's take a look at the bond pricing. So before we can get to the bond pricing, right, using the compound interest equations, first of all, you need to know what is a bond, right? So basically, bond is a debt, and typically it's issued by it's what they call a fixed income security or instrument. So the most typical example is treasury bond, right? So like the federal government issue bond to the general public or foreign countries. So basically, the federal government borrow money from the individual person or the other countries, right? That's a typical treasury bond. And so the bond represents a loan made by an investor to a borrower. Okay, so for the treasury bond, then the investor could be individual, right? Could be you. You have some money available, you want to invest in the treasury bond, you can do that. Investor will be individual, or also be the companies or corporations. Of government or foreign countries, other countries, right? And then the borrower will be the US government, right? Borrower. And typically borrower is a corporation or government. So we have a corporate bond, right? Very popular financial instrument. Also the government bond, right? That's another popular ones. And bonds are used by companies, corporations, states, local governments, federal governments, right? Federal governments also issue to finance projects and then operations. Okay. And owners of bonds are what we call the debt holders. Okay. Creditors or the issuers. Okay. So in the treasury bond case, the owners of the bond will be the US government, right? And then we also call that debt holders, creditors, and other issuers, okay? And this is the basic structure of the bond. So you lend money to the bond issuer, and usually you hold on to a certificate indicating you are the bondholder. Right? So the investors is typically what we call the bondholder. And then the borrower is what we call a bond issuer. Okay. So they are like a counterparty, right? So two parties involved here, borrower and investor. Bond issuer. Okay. So only for any bond, there's always two parties, right? Usually they are counterparties. All right, then there's one of the bond is called zero coupon bond. Zero coupon bond basically look like there's no. So typically for any bond, you will get interest, right? Just like any similar saving accounts, you get interest based on the money deposit in your bank account. And then for bond, usually the bond issuers will pay the bondholders, interest. And zero coupon bond is a very interesting instrument that basically it's a debt security that does not pay interest, but instead, when you purchase zero coupon bond, you get a deep discount. You get a discount, meaning assuming that $10,000 face value, meaning the bond zero coupon bond worth $10,000. It's worth $10,000, but for the borrower, okay, so borrower will render the bondholder $10,000 at the end of the bond period, maturity. They call that maturity. But borrower paid $10,000, right? At the maturity. But a bondholder only pays. I'm gonna give you just a hypothetical case. Let's say $6,000. When they purchase the bond. When they purchase the bond. So this tells us that that the difference of $4,000 in this case, it's the interest. The bondholder collects right over the life of the bond. So this $4,000 is the interest. So the zero coupon bond does pay interest, but it was like one-time interest, right? One-time interest payment at a purchase, and eventually this will become the investment return, right, for the bondholders. And the bond is redeemed at a face value. Okay, so the face value in this case is $10,000. So the bondholder will get $10,000 at the end. Okay. Although they only pay $6,000 for the bond, but they get $10,000 at a maturity. Let's say 10 years from now, the bondholder gets $10,000. And the difference is the interest paid to the bondholder. All right, any question on the zero coupon bond? So the important concept here is a face value. Every bond has a face value, right? Zero coupon bond, typically face value is very important for the investor because that determines how much interest they will earn out of this investment activity. Okay, and now some keynotes about the zero coupon bond. So zero coupon bond is a debt security instrument that does not pay interest, but although on the statement, it doesn't say they pay you interest on a regular basis. And remember, you get a deep discount when purchasing the zero coupon bond, and that deep discount is your interest earned on this investment. And zero coupon bond trade at deep discount, right? Offering full face value or par value. They also call face value par value. It's the same term, right? Just different names. Profits at maturity. Typically, there's a fixed number of years in terms of maturity. Could be 10 years bond, so meaning maturity is in 10 years. And it could be 20 years bond, 30 years bond, right? Totally depends on the issuer. The difference between the purchase price and also the face value indicates investors' return. Okay. So as an investor, this is actually most relevant information, right? You need to figure out. So the difference between the face value and then the purchase price, that's relevant for the investor. Also for the lender. I mean, yeah, for the lender, for the investor, even for the borrower, it's important, like how much interest you have to pay to your investor, right? That's kind of important for them as well. And now let's take a look at one of these example on the zero coupon bond. So how much would a zero coupon bond cost that matures in 10 years? So maturity is 10 years, right? That's given here. And we know this zero coupon bond with a face value $10,000 of the bond market has priced to yield 5.25%, assuming yearly compounding. So here, this is basically a compound interest formula, compound interest problem. Zero coupon bond is a good application of the compound interest. So here, assuming yearly compounding, then we know that the compounding period n equal to 1. Okay. And then the rate, annual percentage yield, it's 5.25%. So I is 5.25%. Okay. Decimal with 0.0525. All right. And then we also know the face value, right? Face value is $10,000. So that's like in terms of a compound interest formula, we call this an ending balance. So ending balance is known, which is $10,000. For an investor, you get $10,000 after 10 years. Okay, that's what this means. So now you want to figure out how much you are willing to pay at this moment. And that determines how much interest you earn from this investment. So basically, we're looking for the present value, right? Present value of this compound interest problem. So we're using the compound interest formula A equal to P times 1 plus R over N to the NT. And yeah, that's it, right? So here, the time T here is 10 years. Okay, that's also important. So once you have all this information, you will just plug in all these numbers into the compound interest formula. We know A is 10,000, ending balance, and then beginning balance. That's what we try to figure out. Or the principal you invest into this zero coupon bond. 1 plus 0.0525 over number of compounding period here is 1, so divide by 1. And the NT, that will be N would be 1 times T is 10 years. Okay. So this basically becomes a problem of solving for the principal amount P times 1 plus 0.0525 raised to 10th power. And if you divide both sides of the equation by the exponent, so the principal equal to 10,000 over 1 plus 0.0525 raised to 10th power. And again, you should put it into the calculator. Let me show you how to get that. In Excel, so you do 10,000 dividing by 1 plus 0.0525 raised to 10th power. Okay, and let's do it. And if you just input it like that, you get a result, right? So that means at the current moment, you are paying $5,994.86 for the bond. Okay. So if you compare this to the actual, the face value, right? The difference is quite large. So $5,994.86. So typically we run it to 2 decimal place. So it's $5,994 and 86 cents. Okay. So this is your purchase price for this zero coupon bond. And if you want to go one step forward, you want to find out what be how much interest you earn for this investment activity. For investing at this zero coupon bond, you can figure out that as well. So all you have to do is using the face value, total return on this investment will be $10,000. That's face value. That's how much money you collect after 10 years, minus initial investment, $5,994.86. And this turned out to be $4,005.14. And if you want to spread out over the 10-year period of time, each year you are earning about $400.51, right, from this investment. And typically for this, most of bonds are quite safe, although they pay, the interest rate is kind of not compared to the stock investment. It's not as high as stock investment, but they are safer. So that's why the safer the investment, they usually pay lower interest rate, right? They pay lower return. That's typically the case, right? Higher risk, higher return, lower risk, lower return. But it's for a lot of people who prefer safe investments, the bond usually it's a better choice compared to the stock investment, right? Okay. Any question on this? Okay, so now try this. I want you to try this one. So now it's the same. What's the price of a zero coupon bond with a par value $8,000 that matures in 20 years? Par value is the same thing as face value. So you are given a face value $8,000, meaning after 20 years you are getting $8,000. It's compounding monthly now. Okay, and if the bond is priced to yield 5.75% in yield, so this is annual return, annual interest, right? All right, so similarly, you're looking for the current price, meaning the purchase price. You're looking for the purchase price. And here we are given the par value, face value. So this is future, this is happening in the future. So A equal to $8,000. You also are given time T, right? Time T is 20 years. Okay. And then it's compounding monthly that tells us the compounding period. So n equal to 12. And then the bond is priced to yield 5.75%. So the annual interest rate is 5.75%. So we are given all this information, and next thing, just basically figure out what is the principal of the initial investment. It's 5.75%. And now we're looking for the principal amount or the initial investment. And now very similar to the previous example, right? So we write a compound interest formula, P times 1 plus R over N to the NT. And again, we throw in all the numbers here. So it's $8,000 principal times 1 plus the rate now turn into decimal 0.0575. So it's 0.0575. Compounding period is 12 times per year. And it's 12 times 20. Okay. So that's basically 240 power. So 8,000 equal to principal times 1 plus 0.0575 over 12 to 240 power. Now all you have to do is dividing both sides of the equation by this exponent 1 plus 0.0575 over 12, 240 power. Same thing on the left is 1 plus 0.0575 over 12 to 240 power. And then you cancel the exponent on the right, and the principal is by itself. And you put into the Excel calculator to get the principal amount. So let me show you what that is. So we do 8,000 dividing by 1 plus 0.0575 dividing by 12 and raised to 240 power. And that should give you the result directly. And we get $2,540 and then 6 cents. Format cell, currency to decimal. So it's $2,540 and then 6 cents once you run it to decimal place. So this is $2,540 and 6 cents. And so you're getting, it's like you get $8,000 in 20 years. Now you're paying $2,540 and 6 cents. And total interest or total return on this investment, let's just get an idea, you know, what kind of return you're looking at. So you do $8,000 minus $2,540 and 6 cents. And the difference is the return on investment. So this is $5,459 and then 94 cents. You can divide that by 20, right? You're going to get an annual return. If you divide that, it's about $270 per year. And this is like fixed income, meaning every year you are earning like about $270, right, over the life of the bond. Okay. If you feel like this is good investment, you can put the money on. Otherwise, you know, you can just look for some other, you know, investment opportunities out there. Okay, but that's actually the mechanics behind all this, the bond, especially the zero coupon bond. Okay. Now I want you to try this one. So consider the bond in example 2, but now the prevailing interest rate for competitive investment increases, so the market price, the bond to yield, market prices the bond to yield 6.25%. Right, so everything else is the same, right? So now ending balance still $8,000. Okay, N is 12, still compounding monthly. Time T is 20 years, right? So the rate is different now. It's yield higher return now. So this is 0.0625. Okay, and then I want you to figure out what will be the principal. How much is the purchase price at a given moment? Okay, you can try this really quickly. I'll give a couple of minutes. And let me ask you something. Are we paying more compared to example 2, or are we paying less for this particular case? Any intuition? Anybody want to share your idea? Okay, no worry. You will see that in a second, right? Once you perform the calculation. So try that yourself. All right, let's quickly get this principal amount for this particular bond. So one more time, apply the formula: principal times 1 plus r over n to nt. Now throwing all the numbers, 8,000. So the principal is what we're looking for, 1 plus. The rate is 0.0625. And dividing by 12 over 12 times 20, so 240 power. So it's turned out to be 8,000 equal principal times 1 plus 0.0625 over 12. Again, keep as is. Do not divide the decimal number by 12. So you lose some accuracy there. And from there, just dividing both sides of the equation by the exponent one more time. And if you cancel the exponent, then we get a principal amount here. See what that is. One more time. Definitely need a calculator or Excel to do that. We go back to the Excel. 8,000 dividing by 1 plus. So now interest rate is bigger, meaning the denominator will become bigger. That indicates when denominator gets bigger, then the total outcome, the numerator stays the same, and the total outcome becomes less. So now if you look at it, you only paid $2,299.49 compared to the previous one, you're paying $2,540.06, meaning you're paying about $245 less, right? which is a much better deal compared to the previous case. So they take 2299, 49. So you're paying less. So meaning when the rate is higher, you're paying less. $2,299 and then 49 cents. Okay, that's what you're paying for. And also meaning if you pay less, you're making more money, right, out of this investment. So the total return should be higher compared to the total return should be higher. So you're using $8,000 minus the purchase price. And now the total return here will be $5,700 and 51 cents. And this is slightly higher compared to this, right? $5,459.94. Yeah, so that means, yeah, this is in terms of the investor, this is a better choice, right? Because the bond paying more interest rate, more interest. Yeah. Okay, and now one more time, determine the value of the same bond in example 2, but now the rate becomes 6%, also compounding monthly, right? Let's see. So this 6% is between 5.75% and also the 6.25%. So it's right in the middle. And that means intuitively, and the bond price should be in the middle of those two options, right? But I want you to really quickly get a result of this. See how much money, how much is the purchase price. I'll give you a couple minutes. All right, so one more time, the rate is 6%. So we turn into decimal is 0.06, and then still is compounding monthly and equal 12, 20 years, T is 20. And we also have a ending balance is $8,000, and then the principal, we're looking for that. So ending balance equal principal times 1 plus R over N to the NT. So 8,000 plus 0.06 over 12. And then that will be 12 times 20. So similarly, 8,000 equal to principal times 1 plus 0.06 over 12. Here, the 0.06 could be evenly divided by 12. So if you want to turn it into a single number, you could do that here, but you don't have to, right? So the principal should be 8,000 and dividing by 1 plus 0.06 over 12 raised to 240 power. See the outcome of this one more time using Excel to get a result. Okay, and then you see the comparison, right? The price, this is for 5.75% interest rate, and this is for 6.25%. Okay. Now we have a 6%. So this is 8,000 dividing by 1 plus 0.06 over 12 raised to 240 power. And this turned out to be $2,416.77. And as you can see, this should be in between, right? Right in the middle of those two amounts. That means the interest rate determines, how much you're paying for the zero coupon bond. The higher the interest, the lower the purchase price. As they go in the opposite direction, meaning the higher interest you are getting more in the return, so you're paying less for the bond. The lower the interest, meaning you're getting lower return, so you're paying more for the bond. That sort of makes sense intuitively. So in this case, it should be $2,416.77. $16.77. Yeah. And then the total return, if you really want to figure out what is the total return on the investment using $8,000 minus $2,416.77, the difference is the total return. So in this case, it should be $5,583.23. Right. Also, return is in between those two scenarios as well. So now, if you want to summarize this, just like 5.25%, is it? Yeah, it should be 5.75%. This should be okay. One more time. This should be 5.75%. I forget to update numbers. Okay, and that's 6.0%. Yep. And then the 6.25%. So if you just summarize all three scenarios from the previous one, from the three cases we examined, so you just need to fill in all these three numbers here from the Excel sheet. I think the first one is $2,540.06, right? That's highest. $2,540.06. Okay. So for the lowest rate, you're paying the most. And then second one is $2,299.49. We just summarize the outcome there, $2,299. And no, that's for this is for last case, for 6.25%. So this is $2,299.49. So the 6% is right in the middle of those two. And this is $2,416.77. $2,416.77. And you'll be able to see this clearly. The higher the rate, the lower the price of the bond, meaning you're getting more return from investments. Okay. So the higher the interest rate, the lower the purchase price. So they have inverse relationship, right? In this case. Okay. Now the last example in this section. So a zero coupon bond that matures in 15 years. So we have following things with a face value $20,000. So meaning ending balance receiving $20,000 in 15 years. Okay, A equal 20,000. And it's available from bond dealer for $13,800. But you're paying less, definitely paying a lot less. So now the present value of the investment is $13,800. And you're looking for the interest rate. What interest rate, compounding monthly, does the bond yield? Right, so R is not given. Compounding period is given, 12 per year. So looking for R. Okay. So now let's get to it. Again, we plug in the formula AP times 1 plus R over N corresponds to the NT. Okay. And now we throw in our numbers. We get 20,000 here. Ending balance. Initial investment 13,800 times 1 plus the rate is what we're looking for, R over 12. And then is, and also T is given, right? I forgot to mention that, 15 years. Okay. Time T is 15 years. So this turned out to be 12 times 15. And that's 180. I raised 180 power. So first one, let's simplify a little bit. 20,000 equals 13,800. 1 plus R over 12 to 180 power. Now, step one, you will just dividing 13,800 from both sides of the equation. Okay, let's do that. That means we drop the coefficient on the right, and then on the left, right, just drop a couple zeros. So you just becomes 1 plus R over 12 raised to 180 power equal to 200 over 138. Here we're going to use this AXY, right? Use the reciprocal power of A to the X raised to reciprocal 1 over X power that becomes A to the first, because reciprocal cancel each other, offset each other. So here we're going to raise both sides of the equation by 1 plus R over 12, 180 power raised to 1 over 180 on both sides of the equation. So on the right is 200 over 138 raised to 1 over 180. Okay. Then the power, they are reciprocal, they cancel each other, so we get 1 plus R over 12 equal to 200 over 138 raised to 1 over 180 power. And here, in order to get R by itself, subtract 1 from both sides of the equation and multiply 12 from both sides of the equation. So R is equal to the square bracket 200 over 138 raised to 1 over 180 power minus 1 and multiply by 12. Okay. And then that's how you end up with the rate. I will put a rate on top. So approximately equal to this. So let's see what that number is. Go back to the Excel. So this is going to be open parentheses and then 200 over 138, closing raised to 1 over 180. Close it minus 1, close the big parentheses, and then multiply by 12. And that's how we get it, the rate. And then just hit enter, you get a rate. And one more time, we're gonna run it to 4 decimal place. And this turned out to be 0.0248. That means that the rate they are paying here is 0.0248, meaning that the rate is 2.48% in this case. And this is quite normal for a lot of bonds, right? It's very reasonable return you expect from the treasury bond, sometimes even lower than this. If you look at the bond yields, this is all public information. You can always look up all these returns on different bonds, especially treasury bonds. The U.S. government usually will release all those information, and this is quite realistic return you're looking at. But still, right, it's very safe investment, right? Because U.S. government never default on any bonds, right, so far. So definitely it's very safe. Usually people consider risk-free investment. For the U.S. Treasury bond, risk-free investment. That's why they have the luxury to pay less interest because of the nature of the risk. Okay. All right, so that's pretty much everything on this part on bond pricing. And let's take a look at one of the examples in the back of the textbook. Let's look at question number 8, right? I really want you to try this yourself right now. And you should be able to figure out this. 8 and 10, right? And we wrap up the exercise from section 3.2. Question 8, question 10. I give you 5 minutes, complete that, and then we move on. Okay, so for question 8, determine the price of a zero coupon bond that has a par value $7,500. Maturity, so this ending balance is A is 7,500. And then maturity is 15 years, time T is 15 years. Okay, and the price to yield 511% compounded yearly. So this rate is 5.11%, 0.0511, and N is 1, right? So that's all given information. And once you have all of this, and then we'll be able to calculate the bond price, principal. And so A equal to P times 1 plus R over N, close parenthesis to NT. One more time, we throw in all the numbers, 7,500 equal to principal times 1 plus, the rate is 0.0511 over 1. Okay, and it's 1 times 15 as the power. So now this is 7,500 equal to P times 1 plus 0.0511 to the 15 power. And principal should be equal to 7,500 divided by 1 plus 0.0511 raised to the 15th power. You get a bond price here.
We can't see what you're writing.
All right, I probably forget to share that. How about now? Yes. Okay. All right. So one more time, we have all this given information, and you just plug into the formula, and the last thing we do is get the result for this purchase price. So go to Excel. So we get 7,500. Let me share. I sometimes forget to share, so then make sure I share that. Okay, 1 plus 0.0511 and raised to 15th power. That should be the bond price, and $3,551.41. That should be the bond price we're looking at. Okay, and $3,551.41. So this bond price is $3,551.41. If you look at the return here, total return. As an investor, this is the most important issue, right? In terms of looking at this return. So using 7,500 minus $3,551.41. The difference is the return on investment. So this should be $3,949. No, $48.59. Yeah, $48.59. Okay, so this is total return on this investment. And do you have any question on this? On question 8?
Yes, Professor.
Yeah.
Did they ask for the total return, or are we just doing it for ourselves?
They didn't ask for it. Yes, you're right. They didn't ask for it, but it's better, calculate that. Remember, this is all come from. You can use it to guide your real life investment, right? So you know what you're looking for. Like in terms of comparing the returns, which investment is better off. You will need this information, right? Okay. But also, the lower the purchase price, the better it is, right? That's usually, you know how that goes. Yeah. All right, but no, the question did not ask for that, right? For sure, you don't have to calculate this if you don't want to. Yeah. I just want to put it up there for you to understand. Okay, and then question 10. For the bond in example 8, right? Still, we're talking about the same bond. Now, the price, determine the purchase price. If the interest rate on the bond increased to 5.31%, according to the empirical rules, the higher the interest, right? It should be the lower the purchase price. And let's see if that's the case. So we have all the same information here, except the rate. So still ending balance still 7,500. Okay. We also have time t is 15 years. Compounding period is once per year. And here the rate is 5.31%. Intuitively, we know that it should be lower purchase price, but it's very straightforward to confirm that using the formula. So A equal P times open parenthesis 1 plus R over N raised to NT. One more time, and I'm throwing all these numbers. 7,500 equal to P times 1 plus 0.0531 by 1. And this is 1 times 15, still the same. 1 times 15 is 15. So we end up with 7,500 equal to principal times 1 plus 0.0531 raised to 15th power. Now the principal equal to our initial investment, 7,500 over 1 plus 0.0531 raised to 15th power. And one more time, I'm throwing to the Excel or calculator. Let's get a result here. So we do 7,500 dividing by 1 plus 0.0531 and raised to 15 power. And that should give us a result, right? We expect to pay less. How much less? Is about $100 less, right? Still, it's better, meaning you're making your interest, your return on investment is $100 more. So usually it's a slightly better case, right, compared to that. So it's $3,451.57. $3,451.57. So lower purchase price, also higher return. So if you look at the return, total return, investment, it is 7,500 minus $3,451.57, and this should be $4,048.43. Okay. And compared to that, it's slightly better. $100 more, right, in terms of return. Okay, so we'll basically just wrap up the this is section 3.2, and we look at some of the financial instruments, right? Continuous compounding, APR, right? Also the bond pricing. Okay, we look at a very simple case of zero coupon bond here. Now let's continue on section 3.3 about annuities. So we're going to look at more financial instrument here. So and let me just open the file really quickly so we can get to that. So there are several type of annuities, right? Annuity have two major categories. One of them is called annuity at the present time, annuity at future time. And we're going to look into both of them. They both very useful and an interesting term, you can learn from and then use it in the real life. Okay. First one, let me share the PowerPoint. So I post the PowerPoint from section 3.3, and section 3.3 is mainly about annuities. Okay, and then we're going to take a look at definition of annuities, right? So we have one of the key aspects of annuity is a level stream of cash flows. Okay, it's like for a fixed period of time, and we usually call this a fixed payment. Right? So one of the most important elements in the annuity is a fixed payment for a fixed period of time. And each payment is the same amount. Okay. Second important element, regular payment often referred as PMT. Fixed payment is also called regular payment. And you probably heard this from the mortgage, right? If your parents have a house, they probably borrow money from the bank, any bank. And usually on a monthly basis, they pay back a fixed amount, right? And that's what they call the regular payment. Right? Or if your parents have a car loan, they usually pay back. Let's say you borrow $40,000 and then get a car, right? And typically you pay back to the bank on a monthly basis. Let's say $800 per month. You pay back to the bank for like maybe 5 years. And that's what they call the annuity, right? The car loan, mortgage, they all annuities, right? And the time between PMT, the fixed payment is always the same. So for most of the financial instrument like mortgage, saving plan, car loans, you pay on a monthly basis, right? You pay back the loan on a monthly basis. So the time between regular payments will be 1 month, right? And we have also the ordinary annuities like saving plans, mortgage, and car loans, and the fixed payment PMT is always made at the end of each period. Okay. And also the day you sign your contract, you do not make a fixed payment or regular payment. You do not make a PMT. So usually bank will give you 1 month grace period, right? It's like a 1 month break. And after the first month, you start paying the regular payment, right? And annuity due, the fixed payments are made at the beginning of each period, right? So lease contracts. So if you lease for a car, right? So usually you pay the fixed payment at the beginning of each period. So this is for all the leasing contracts. But for mortgage, car loans, that's usually not a leasing contract, right? It's ordinary annuities. So that's different type of annuities, and then the fixed payment just come at a different time. But we typically focus on the mortgage, car loans, right? Ordinary annuities. And that's most popular financial instrument people use in their daily life. So one more time, 2 important things about the annuity is a fixed payment, a regular payment, right? And also fixed number of time and fixed number of time. Fixed number of payments, meaning over the life of the mortgage, let's say it's 30-year fixed mortgage, then you're making 360 payments, right? So for example, like 30-year fixed mortgage or car loan, something like that, you are paying 360 payments. How do you know it's 360? It's compounding monthly, so 12 compounding period per year times 30 years, right? So it becomes 360 payments. That's how you arrive at these total payments. Maybe 15 years fixed mortgage, that'll be 15 times 12, 180 payments to the bank, fixed payments. And for example, those are the 4 typical examples of the annuities. So first one is a saving plan. If let's say you have some extra cash on the side, right? If you put away $50 in the bank at the end of each month for 50 years, how much will I have until when I retire, right? And what is the future value of that? So this is a typical annuity issue. And this is also like retirement account. All the retirement account work in a similar way, retirement account. What we mean by retirement accounts, very popular ones are 401k, 403b, right? Those are the popular retirement accounts. And yeah. So second example is a future value of the future cash flow valuation. If you want to be a millionaire, let's say you want to save by the end of 30 years, you want to have $1 million. And how much do I have to put in the bank at the end of each month? And in order to have $1 million, right, when you retire. So this is also like annuity issues. And this is very, so if you have a retirement account, you can also monitor your retirement account. If you work for any companies, they usually will offer you a retirement account, 401k, 403b, and you can contribute money towards your retirement account. And when you retire, you'll be able to have a big balance in your retirement account and start withdrawing the money from the retirement account and then pay meet the future financial needs, right? That's how that goes. Also, we have a loan. Typically, popular loans are mortgage or car loans, right? Or even credit card is a loan, right? Think about it. If you have a credit card, you're borrowing money from the credit card company. So that's a loan to you. And you have to pay back on a monthly basis, right? So let's say you take out a loan for $190,000 and you want to figure out the monthly payment. Okay, amount payback to a bank on a monthly basis. And also, if let's say some asset will give you $10,000, right, regular payment at the end of each year for the next 15 years. And this is trust. A lot of trust works this way, right? Let's say your grandparents have a lot
From Dunkin' Donuts.
Your famous.
No, I don't think I want a latte. Do you have your phone?
I'm going to get it.
Okay, so let's continue here. All right. So if let's say your grandparents set aside a trust for you to receive $10,000 at the end of each year for the next 15 years, and then your grandparents want to figure out how much they have to deposit right now, right, in order to fund this stream of cash flows for the beneficiary to receive $10,000 for 15 years, right, in a row. And that's all kinds of different annuity examples. Now let's take a look at. So property of annuities. So we have two types of annuities. One of them is the future value of the annuities. One of them is present value of annuities. So you look at the mortgage or car loan. Or any loan or credit card, right? That's a present value of annuity because the lump sum payment here, lump sum payment, if you get a mortgage from the bank will give you let's say you borrow $300,000 in your mortgage application, and the bank will hand you $300,000 right now, right? So the lump sum payment or one-time payment, also called one-time payment, will come at the present time. Okay. So one-time payment comes at present time. So this is the present value of the annuity. So another important element is the lump sum payment or one-time payment. In the annuity case, so this one-time payment comes before the regular payment. So before you pay back to the bank will hand you $300,000, right? So the borrower will get $300,000 right now. So borrower gets the one-time payment, a lump sum payment right now, and then pay back on a monthly basis. Pay back the bank on a monthly basis. Same thing with the car loan, right? If you want to get a loan to finance the purchase of a car, and let's say bank give you $50,000, you get it right away, you use that to purchase the car. And then after that, a month from there, you pay back a regular payment every month. So let's say if you borrow $50,000, you pay back $800 on a monthly basis for 5 years, right? Eventually you pay off the loan. Credit card is the same. Let's say you borrow $1,000 to purchase iPhone, and credit card company will give you $1,000, right? You swipe the card, they give you $1,000. You get an iPhone. After that, on a monthly basis, you pay back. Let's say you pay $50 for like 12 months. No, it doesn't add up, right? It's $50 for, let's say, 24 months. And eventually you pay off your credit card debt, right? So those are the present value of annuity. For the future value of annuity, or the retirement account, right? Or trust fund, retirement account, like 401k, 403b, those are the future value of the annuities, meaning the lump sum payment comes in the future. So in your retirement account, once you keep contributing on a monthly basis, eventually when you retire, you're going to see hopefully you see a big balance on your, let's say, $800,000 or $1 million in your retirement account. And that lump sum payment comes in the future. Meaning you will see that big balance in the future. So that's what we call the future value of annuity. So those two are major categories. Also the typical like applications, right? Like mortgage, car loan, credit card, those are the present value of annuity. Retirement account or trust fund, right? Those are the future value of the annuity. You get a lump sum payment in the future, okay? All right, so two important things of the annuities, fixed payments or regular payments, PMT. Second thing is one-time payment. One-time payment or lump sum payment. If you see these two elements in a typical financial instrument, typically you should realize it probably would be an annuity. Okay. Now let's look at the formula for the future value of annuity. So for the future value of annuity, typically you can think retirement accounts or like trust funds, right? You can always relate those to these two type of financial tools. Okay. So here we still work with so F represents the future value. We work with this formula. F is future value of the annuity. R represents regular payment or PMT, right? Or fixed payment, regular payment, or PMT. You can use either one of those interchangeably. And then R represent annual interest rates, okay, just like the compound interest formula, same notion. N is number of compounding periods per year, and T is the time years. Okay, if you look at the formula, so here regular payment times square bracket open parenthesis 1 plus R over N to the NT, and then dividing by R over N. Okay, you can also look at it as R over N is interest rate per compounding period. So that's basically what that is. Okay, so keep in mind this is future value of annuity. And we also have a present value of annuity, right? Okay, so present value of annuity, we have a P represent present value of the annuity. R is the regular payment or fixed payment or PMT. Here R, capital letter R is regular payment, right? And then lowercase r, that's annual interest rate. And N represent number of compounding periods per year. And T represent time T in years. And anytime you're talking about present value, you can relate it to saving account, mortgage, car loan, or credit card account. All of these are the present value of the annuity example. And sometimes it's easier to relate it to a certain, financial tools you utilize in your daily life, right? Like credit card, probably everybody have a credit card. So it works very strictly using this, applying this formula, you'll be able to figure out the regular payment or like the present value, of the annuity, something like that. Okay, now keep in mind those we are using. So basically, we focus on using those two formulas to experiment with those two financial instruments. Okay, so for example, let's say you save $500 a month. Okay, and account typically this one works like a retirement account, right? Like 401k, you basically contribute certain amount of money towards the retirement account, and the money keep growing. So by the time you reach your retirement age, then you actually have a big balance in order to meet the financial needs after you retire. So this one yields 5% compounding monthly. And how much will be in the account after 10 years? So now think about this. This is a PMT, meaning this is a fixed payment, $500. But another question is, this lump sum payment, is it present time or future time? Is it kind of present time or future time? See how much will be in the account after 10 years, right? So after 10 years, that's future time. So this represents future. So in the near future, in 10 years, so that's a future value of the annuity. So this lump sum is in the future. So once that is clear, then we know that we're going to use future value of the annuity. So we need to know some given information here. So the PMT, or regular payment, is $500. Okay, that's one thing we know. And time T is given, right? T is 10 years. Okay. And also the rate is given, 5%. Okay, so it's 0.05. We also know that compounding period, right? It's compounding monthly. So that means n equal to 12. Now again, we using the future value of the annuity from the previous slide. Okay, you can go back quickly look at that. So this is the future value of the annuity formula. So the future value of the annuity equal to regular payment times 1 plus R over N to the NT minus 1 over R over N. So here we're looking for the future value of the annuity. So future value is unknown. And the regular payment, we know that the rate, we know that N is 12, T is 10. Okay, so we can just throw into this formula and get the future value of the annuity. So it's 500 times 1 plus 0.05 over 12 NT, that's 12 times 10 minus 1. And then dividing by the rate is 0.05 over 12. Now again, you can just use the Excel to get a result right away. You have to use either full calculator or Excel, right? Otherwise, it's going to be a very long calculation there. So we're going to do 500 times open parentheses from the numerator. Okay, so it's 1 plus 0.05. over 12 raised to 12 times 10, n minus 1. That will take care of the numerator and divide by the denominator, put in the parentheses 0.05 over 12. Okay. I give you some time to look at this formula really quickly, since this is first time we're using the future value of annuity. Okay. And once you have the right input, then you get a result right away. Okay, let's see what that is. And this turned out to be $77,641.14. That means that's what you have in 10 years, $77,641.14. Okay, so that's the future value of the annuity, 77,000. 641 and then 14 cents. 641 and 14 cents. Okay. Now this is what you get in the near future, right? But let's think about it. Like how much return do you generate from this account, from this retirement account? So let's look at total return on investment. Actually, that's kind of a useful information. So now think about it. You're getting total of $77,641.14, right? In 10 years. But let's look at the contribution towards the account. So each month you contributing $500. Every year you contributing $6,000. So 500 times 12. That's annual contribution. Remember, you're contributing 10 years. Okay. So eventually you end up with the total return. So it's $77,641.14 minus. So that's going to be 500 times 12, 6,000 by 10 is 60,000. That means the total return on investment is $17,641.14 in 10 years. That's the return on investment, total return. Or you can say that that's interest earned on this retirement account. Okay. So this is future value of annuity. So one of the important things to distinguish the future value and the present value is look at the lump sum payment, whether it's in the present time or in the future time. If it is in the future, meaning that one-time payment or lump sum payment comes in the future, then that's a future value of the annuity. If the lump sum payment comes at the present time, that will be the present value of annuity. Okay. Let's look at one more example. So you want your retirement account to reach $1 million, right? So this is a goal. How much should you deposit each month in account payment? Actually paying 5.44% compounding quarterly to reach this goal in 30 years. Okay. So you look at what's given here. Right? So you want to retire with $1 million. So this $1 million actually is in the future. So you have a future value here, which is $1 million. So one with the 6 zeros in the back. Okay. So looking at future value of $1 million. And you also given the rate. Rate is 5.44%. So turn into decimal is 0.0544. And compounding quarterly, that gives us a compounding period on a yearly basis. So A equal to 4, right? 4 quarters in a given year. And then time T is also given. Time T equal to 30 years. Okay. And we are looking for the deposit each month, right? Meaning the regular payment or monthly payment. So regular payment, that's what we're looking for. Okay. So still, this is about future value of the annuity because it's a retirement account, definitely a future value. So future value of annuity equal to So we have this, I think. So we just apply the formula, regular payment times 1 plus R over N to the NT minus 1 over R over N. Okay. So right here, you're gonna put in all the given information and solve for the regular payment R. So the future value is $1 million, and the regular payment, that's what we're looking for. And here we go, 1 plus rate is 0.0504 over 12 over 4. And that's going to be 4 times 30, 120 times, right? So you are making 120 payments, monthly payment towards the life of the retirement account. And here dividing by 0.0544, dividing by 4. And from here, we will solve for the regular payment. So what we want to do is multiply by reciprocal of this fraction. So you multiply by this. So it's going to be 0.0544 over 4. That go on top, right? And dividing by the denominator, which is that. So it's going to be 1 plus 0.0544 over 4 and raised to 120th power, which will be an open parenthesis here. Shouldn't be a square bracket. Open parenthesis here, open parenthesis to the 120th power minus 1. Okay, that goes on both sides of the equation. So on this side, you multiply by this whole thing 0.0544 over 4, dividing by square bracket 1 plus 0.0544 over 4 raised to 120th power minus 1. Okay. And that should give us the answer, right? And let me quickly show you how to input this in Excel. So this cancel the denominator, this cancel the numerator. So you get that. Okay. So here we go. So we get $1 million. Okay. 1 more 0 times 0.0544 by 4. That will take a numerator and divide by the denominator. That's going to be open parentheses 1 plus 0.0544 dividing by 4 and raised to 100. Open parentheses, it's okay, to the 120th power, because 30 years times 4, yes, 120th power. Under 20th and minus 1. And we close the parentheses and get this. So the monthly contribution should be $3,351.27. Okay. All right. That should be the monthly contribution, $3,351.28. So the regular payment here is approximately $3,351. And then 28 cents. So if you contribute this amount towards the account for like 30 years, you'll be able to reach $1 million by the end of the 30 years, right? By the end of the retirement age. Okay. And do you have any question?
Professor, can you
Yep.
show the formula on Excel just once again?
Definitely. 1 second, let me show you that. Yeah, sure. Here you go. I think that's a typo in the PowerPoint on that. I will modify that. I will upload the PowerPoint one more time. I think there's a typo there.
Thank you. That's fine.
No
Thank you.
Okay, very good. So this is that's all, right? So that's all for today. We continue on Friday. Okay. I'll talk to you guys on Friday.
Thank you.
Thank you.
No problem, guys.
Good day.
Bye-bye. Okay, bye.